Hello, What Ifers, and welcome to the latest installment of What If Extended. What If Deep Dive? No. What If the Movie? No, but that does sound interesting. How about Dateline What If? Yeah, I'll take it away and I'll workshop it and I'll get back to you later. But we'll just leave it as a What If marathon for now. Anyway, today's focus is on that infamous dwarf planet in the Kuiper Belt, the former ninth planet in the solar system, Pluto. Now, I take no joy in the fact that Pluto is no longer classified as a planet. I accept it as a scientific fact, not gonna argue it like some of you in the What If community. I'm just gonna embrace it and move on. Sometimes things that are 5.8 billion kilometers away aren't what we originally thought they were. Heck, sometimes things and people on our own planet aren't what we thought they were. Coming up in the marathon, we'll find out what a sunset looks like on Pluto, what it would be like to die on the dwarf planet, and what life on Earth would be like if our planet were the same size as Pluto. Hint, it's not going to be great. But first, before we get to all that, let's get to know the place a little better. I sent our trusty crash test dummy, our experimental regenerating lizard man Chase, to set foot on Pluto and find out what it's really like on the surface.
What up, guys? You asked and I delivered. I'm here on Pluto, and I'm gonna give you 3 reasons why Pluto is a planet, baby. Why? Because someone's gotta stick up for this little guy. Look at him, he's so cute.
Analyzing conditions. Atmosphere, nitrogen, traces of methane, and carbon monoxide. Current temperature, minus 232 degrees Celsius.
Yeah, oof, that's chilly. Well, that makes sense. Pluto is 6 billion kilometers away from the sun. So what makes a planet a planet? It's literally just 3 things. The first condition is that it has to orbit a star. Check please. The sun is barely visible from here, but it's there, and Pluto orbits it, so Pluto 1, haters 0.
Distance to the sun, 5,867,639,023 kilometers.
Exactly. It's like 0.1% the brightness here that you've got over there on Earth. It's really dark, right? Hey, I think I see some mountains over there. Gotta check them out. Rico, remember that time we watched Mean Girls?
Negative.
You know, it got me thinking about, like, every time I've been bullied or rejected by all those alien hotties I ask out. I mean, that's not important. And no one has been more bullied than Pluto. For like 80 years, it was considered a planet. And then, like, out of nowhere, it becomes a dwarf planet? Like, what's up with that? Thanks, Neil deGrasse Tyson.
Pluto was disqualified as a planet due to the discovery of large objects around its orbit.
Man, who didn't they punish back then? First Lindsay Lohan, then Britney Spears, then Pluto loses its status. Man, the 2000s were cruel. Yeah, this is definitely a mountain, and that's something a planet would have.
The presence of landscape elevation is not part of the planet definition specified by the International Astronomical Union.
But I mean, like, alright, but what if the mountains have water ice? I mean, look at this stuff. That is ice!
Many non-planetary bodies feature these landscape traits.
Right, yeah. I mean, I knew that from my various trips to moons and the suches. Alright, I tried to score some points for Pluto here, but Rico is being real annoying with his International Astronomical Union or whatever. But he's right. There are technically 3 criteria for a planet to be a planet. And number 2 is that it needs enough mass and gravity to form into a sphere. Some asteroids out there have wild shapes. None of them are flat though. Sorry, flat earthers. You guys are still wrong. There's a comet shaped like a bone and a cigar, and this one looks like a rubber ducky. That's a good one. So all of these wild shapes occur because they don't have enough gravity to turn into a sphere shape. But Pluto does. I mean, look at it. It's round. Pluto 2, haters 00. Speaking of haters, I read some of your comments the other day, and gotta say, some of you hurt my feelings. You think I'm AI? There's no artificial intelligence in this handsome space explorer. Everything you see is real. Go over to Patreon, see what I mean. Now, back to Pluto.
You are forgetting the 3rd criterion for planet qualification. A celestial body must have enough gravitational force to clear the area in its orbit. Pluto shares its orbit with small, icy bodies in the Kuiper Belt, so it cannot be classified as a planet.
Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet. Pluto had it coming from the beginning. Just, get over it.
2 out of 3 ain't enough? Ugh, man, the Astronomical Union are such keeners. I mean, Pluto has enough mass and gravity to form it into a sphere, but not enough to impact the objects around it? Ugh, seems pretty arbitrary to me. So basically, it got kicked out of the Planetary Cool Kids Club for being too skinty? Ugh. Whoa! 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 Rico, you're supposed to warn me about these kind of things. Bad things tend to happen to me.
Acknowledged. Danger. Crater detected in front of you.
Are you serious? Yeah, I see the crater, Rico. Thanks. Damn! Look at this thing. It's huge.
Craters on Pluto range up to 260 kilometers in diameter.
Whoa. Isn't that like half the size of this boulder?
Pluto is 2,376.6 kilometers wide. That's 2/3 the diameter of the moon.
What? 2,400 kilometers? I mean, like I could walk that in 4 days.
Inaccurate.
I mean, okay, maybe not walk, but if I ran, I could for sure do that in 4 days.
The average maximum run speed of a humanoid is 8 kilometers per hour. You are well below average human.
Okay, Rico, all right, enough of that. It's still a very small planet, though.
Still not a planet, but yes.
Right, so Pluto's giving dwarf planet, so we just need to figure out a way to bulk it up. Give it a little ass steroids, you know? Make it a heavyweight champ. Oh, I've got it. Pluto lives in the Kuiper Belt, the region of space just beyond Neptune's orbit, and that place has a ton of icy objects and asteroids. Some of these guys are pretty big. I mean, not big enough to be called planets, but maybe if we put them all together, we could make the biggest planet of all time.
Calculating the likelihood of creating the biggest planet of all time. 0.0005%.
Rico, buzzkill, okay? I was being hyperbolic.
I cannot compute tone.
Okay, well, not the biggest planet of all time, but bigger than it is today. Let's see, if you... Okay, so you gotta take the mass of the... Okay, actually, I don't want to do this math. Rico, calculate Pluto's mass if it absorbed every object in the Kuiper Belt.
New mass would be 6 times 10 to the power of 23 kilograms. New diameter would be 8,500 kilometers.
Yeah, okay. Well, that's super clear, but maybe also just for the people in the audience who didn't get that, could you explain it better?
Pluto would have a greater mass than Mercury, and almost as great a mass as Mars. It would be wider than many planets, including Mercury and Mars.
Yes, let's freaking go, baby! That would definitely make this a planet classification. Rico, let's make this happen.
Assessing risk. Disastrous consequences foreseen.
Once again, Rico, you insist on being a buzzkill, okay? We're trying to make a planet here. Who knows? Maybe it could even be habitable.
Extremely unlikely. Slow rotation suggests no magnetosphere. Location far outside the habitable zone of the sun. No hard evidence of an existing ocean.
Okay, okay, I see your point on this one. The heck? What is this? Get it? Who? Okay, someone needs to fire this editor. But still, we could deliver Pluto justice. Bring it back to the mainstream. Everyone deserves a second chance. Like Lindsay Lohan with those Netflix movies. She's killing it. So it's clear that Pluto is currently not a real planet. It's a dwarf planet. Sorry, I know this must be disappointing. But not to worry, I have a plan to make Pluto a true planet.
Disastrous consequences foreseen.
Okay. Disastrous this, disastrous that. What is it that you are so concerned about, Rico?
Pluto and Neptune cross orbits at 2 points. Currently, they are in orbital resonance, which means their orbits are locked in a repeating pattern, preventing them from ever getting too close and colliding. If one gravitational force changes, the planets risk collision, and absolute destruction of the solar system may ensue.
Well, that doesn't sound good at all. You know, I really thought we could find a redemption arc for this little guy, you know? I thought he was big enough. I thought he could go the distance, but I guess not all fallen heroes are meant to be redeemed.
Hazard detected.
Have you ever had to downsize? Your house or apartment's too big for you and you don't need all that space anymore? Most of us are familiar with the need for more space, not less. Maybe you need extra bedrooms, a bigger kitchen, a garden, or maybe just more storage for all the useless stuff we keep accumulating. Downsizing can be much harder. You have to get rid of some of that stuff. You might lose certain aspects of your previous home, and there's a lot less space to move around. Well, consider yourself lucky that you're just downsizing your home and not the entire planet. What if we downsized Earth to the size of Pluto? It's a small world after all, because today we're shrinking Earth to the size of Pluto. But if our planet was this tiny, how would it alter the atmosphere? Why would Earth get hotter? And how would gravity affect our water supply? This is What If, and here's what would happen if Earth was the size of Pluto. Pluto sits on the solar system's edge, just beyond Neptune's orbit. It was once considered a planet, but then in 2006, scientists demoted this celestial body to a dwarf planet. All because Pluto isn't big enough to gravitationally dominate in its own orbit. After all, this dwarf planet is only 2/3 the diameter of our moon. So if Earth was as tiny as Pluto, how would 8 billion people fit on it? Say goodbye to your personal elbow room. We would have to fit everyone into an area slightly bigger than Russia, 71% of which would be covered with oceans. But the good news is, this shrunken Earth would still have room for everyone. Just barely. You and every person on the planet would have about 1.5 tennis courts to yourselves. The problem is, that doesn't take into account the space we need for hospitals, airports, and roads. Once we build those, things would start getting cramped. Add to that all the uninhabitable areas like deserts and mountains, and you won't have enough room to comfortably fit everyone. But if you're looking for a quick escape, it would be easy for you to make a break for it. One jump could catapult you almost 7.6 meters into the air. And that leap would last for almost 10 seconds, giving you a spectacular view of the horizon. You could also run faster since there would be less friction. But watch out for slick surfaces. They could send you flying long distances because there wouldn't be enough gravity to keep you in place. And refrain from overexerting yourself with all this running. On this dwarf planet, the air pressure would also be small. So no matter where you're at, it would feel like standing on a mountaintop 5,000 meters high. Yeah, with less oxygen to breathe, you would be constantly gasping for air. If you're lucky, this high-altitude sickness will leave you lightheaded, but if you're unlucky, it could kill you. But even that wouldn't be the worst-case scenario if the Milky Way always had a mini Earth. Technically, the lack of gravity would make Earth uninhabitable. A study out of Harvard from 2019 found that a planet needs a mass of at least 2.7% of the Earth to keep water on the surface. If Earth had formed to be the size of Pluto 4.5 billion years ago, it would never have its mighty oceans. Now, how would this affect the Moon? Well, Pluto's largest moon, Charon, doesn't orbit the dwarf planet. Instead, the two bodies are tidally locked with the same sides always facing each other. Our dwarf Earth would be forever facing the Moon in the same position, locked in place by a common center of mass caused by our competing gravitational pulls. But all of this would be the least of our problems. If Earth was this small, its inner core would be much cooler. Now, that might sound good at first. Earthquakes would stop because there wouldn't be shifting tectonic plates anymore. Volcanoes would become harmless mountains. But unfortunately, Earth wouldn't have a protective magnetic field without the hot molten core. With this gone, the radiation from the sun would fry our planet. Now, what if Earth wasn't formed to be the size of Pluto? What if, instead, it suddenly shrunk? Well then, our planet would keep its mass, but that would make the surface gravity 30 times stronger than what it is now. With intense training, the human body can survive on a planet with 4 times the Earth's gravity, but a planet with 10 times the gravity of Earth? That would break your bones. If you weighed 75 kilograms before, now you would weigh around 2,300 kilograms. Every move you make would take serious muscle power, and you may not have it in you, no matter how hard you try. An instantaneous dwarf Earth would cause mass devastation. It could destroy everything we love about this planet and leave humanity hanging on for dear life. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA Spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into popular science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. If you landed on Venus, this hot planet would crush you like a plastic bottle. It would be painful, but don't worry, it would only last 5 seconds. The longest 5 seconds of your life. And just wait till you see what happens on Mars. It's unsettling. Venus has an extremely dense atmosphere, and with that dense atmosphere comes crushing pressure. Literally, it would crush you. The Venusian atmospheric pressure is 92 times higher than the pressure you experience on Earth. It would only take a millisecond before it started crumpling your spacesuit. After 1 second, your suit's integrity would be compromised. You'd be trapped in the imploding spacesuit with no way out. And that's when your body would begin to collapse. In the next 2 seconds, your skin and muscles would compress, your blood vessels would pop, your organs would fail. Finally, you'd lose consciousness, and just like that, you'd be gone. Venus looks like a beautiful place, but it's deadly. And being crushed by extreme pressure is just one of the many ways you'd die here. Remember the dense Venusian atmosphere? Well, not only does it create crushing pressure, but it also generates the greenhouse effect. Yeah, Venus is hot, instantly boiling your insides kind of hot. Even if you could somehow withstand all that bone-crushing pressure, the heat would get you.
Oh yeah, this feels hot, like being toasted. Like bread being toasted. You guys know what toast is.
Warning, internal temperature rising.
The surface temperature on Venus reaches 465 degrees Celsius. That's almost as hot as the lava coming out of Earth's volcanoes. You'd be feeling the effect of this intense heat within seconds. After 1 minute, your internal temperature would start rising. Cue heat exhaustion.
What if, Guy, I don't feel so good.
Body temperature, 40 degrees Celsius and rising.
At this point, you'd experience nausea, fatigue, and extreme sweating. Your internal organs would start to overheat.
It's getting dark. It's getting dark.
After 10 minutes, you'd lose consciousness. Now, you'd just have minutes left before suffering brain damage and complete cardiac arrest. On this planet, heat stroke is no joke. Nothing's a joke here, really. The Venusian air is unbreathable. It's made up of 96.5% carbon dioxide and 3.5% nitrogen, which means taking just one breath of this atmosphere would suffocate you. And if that's not enough, Venus's sulfuric rain would corrode your spacesuit and burn your skin. As far as the survival situation on Venus goes, it's a 1 out of 10. Would not recommend. Now this is Mercury.
The closest planet to the sun, like I haven't just suffered a massive heat incineration already? Come on, what if, Guy?
Well, Mercury has a little secret. It's actually extremely freezing, at least on the night side.
Surface temperature, minus 180 degrees Celsius.
Yeah, of course. I knew that. Everybody knows that. And here, I'll let you in on a little secret. What If Explorers Club on Patreon is on a roll. That's right, get access to early episodes, and you can see me die. A lot. I die a lot.
Here's the thing about Mercury. Unlike its planetary neighbor Venus, it doesn't have an atmosphere. And without an atmosphere, there's nothing to trap the sun's heat and keep it close to the planet during the long Mercurian nights. Even though Mercury is just 58 million kilometers from the sun, as soon as night hits, it cools down rapidly. When you first land, you'll be okay. You could walk around and explore the planet.
Yeah, Rico, there's like a little numbness in my fingers. Is that normal?
Numbness in the extremities indicates the early stages of hypothermia.
Nah, I'm okay. It's like minus 180 degrees here, you know? Of course it's a little chilly. What a shocker.
Hypothermia would take a little time to kick in. It starts with a tingling feeling in your fingers, then suddenly you begin to shiver.
Yeah, I don't feel any shivers. Okay. Maybe I feel a few shivers, but it's not that bad.
Warning, your body temperature has dropped to 35 degrees Celsius.
Can't feel my fingers.
After 10 minutes in this extreme cold, you'd barely be able to move.
Warning, core body temperature at 32 degrees Celsius. Return to the spaceship immediately.
Your muscles would feel stiff. You'd feel confused and cold.
There was at least 102 Dalmatians.
You'd feel extremely disoriented. Everything would slow down for you. But you wouldn't die. Not yet.
Warning, core body temperature now 28 degrees Celsius.
Even now, you'd still be alive. You could barely function, but you're alive. It would take about 60 minutes for Mercury's dark side to kill you. Slow, cold, and painful. But hey, at least you'd get to see some of Mercury's views before you collapsed from the extreme cold. I'd give Mercury's night side a 3 out of 10. But Mercury has a day side too, and it's burning hot. The temperature here hits 427 degrees Celsius, just slightly cooler than the temperature on Venus. And it's not the intense heat that would kill you, it's extreme radiation too. You'd feel all of it the moment you stepped out of your spaceship. Your body would start overheating. If you didn't have the protection of your spacesuit, your skin would immediately get radiation burns.
My hands! My hands are burning! Ah!
It wouldn't be pretty. All that radiation would quickly damage your DNA. It takes 1/1000th of a second to kick off that process. Within the next hour, your cells would mutate and die. So make sure to wear a spacesuit, no matter how hot it feels.
Danger. Core body temperature increased to 39 degrees Celsius.
After 5 minutes of these burning conditions, you'd begin to feel the effects of hyperthermia. If your suit's cooling system were to fail, you'd experience an amount of heat you've never felt in your life.
Oh, God, it burns! My hands! Oh, it's like they're on fire! Oh, it's exactly like they're on fire! Ah.
This sudden overheating would make you nauseous. After 10 minutes, you'd be like a piece of toast. Your body temperature would hit 42 degrees Celsius, and if you've ever had a fever like that, You'd know at this point, you'd be in delirium.
I swear, there were 103 Dalmatians. Everywhere! Dalmatians everywhere!
Exactly like that.
Rico, are you a Dalmatian?
Your muscles would become weak and your organs would start to shut down. Now you'd be unconscious, in the middle of having heat stroke and being blasted by radiation. At this point, you wouldn't have long. Hot side of Mercury rates a 2 out of 10 from me. All right, let's look at Mars. The red planet sounds a lot more promising. Where else in the solar system would you want to establish a human base? Well, not so fast. Mars sits just outside the sun's habitable zone. It doesn't have water or a magnetosphere. Its atmosphere is incredibly thin. It's not a place you could settle into comfortably.
What do you mean? Mars is great.
That is, until you try to breathe on it. On Mars, the air is mostly made up of carbon dioxide. You'd have to keep your spacesuit on at all times, because if you didn't, you'd die.
Spacesuit breach detected.
It only takes a minor suit malfunction for Mars to kill you. The first few seconds of inhaling the air on Mars would feel confusing.
What's confusing about this? I'm dying!
You'd be gasping for oxygen and starting to breathe more rapidly. At the same time, your breached spacesuit would start to decompress, and that would be truly awful. The atmospheric pressure on Mars is only 0.6% of what you have on Earth. As soon as your spacesuit gave in, all the pressure inside it, the pressure keeping you alive, would escape.
Warning. Danger of embolism. Warning.
Embolism is what happens next. As your suit's pressure suddenly dropped, your body would experience painful, blood-boiling conditions. You see, your blood and other bodily fluids have gases inside them. Exposed to the low-pressure environment on Mars, these gases would boil. Your skin would swell and puff up. After about 7 minutes, you'd be dead. This is going to be pretty graphic. Somebody put a warning on the screen. Mars would give you hope, and then gruesomely kill you the first chance it got. I'd seriously reconsider coming here, because even if you made absolutely sure that your spacesuit was safe and wouldn't suffer a life-ending breach, Mars will find another way to wipe you off its face. And that other way would be dust storms. Dust storms on Mars are wild. They can cover the entire planet, and they last for weeks or even months.
Can't see crap in here.
It's not that those storms are strong, they're not, but the dust particles are so fine that they get into your spacesuit easily and scratch it from the inside.
Oh man, what? Matt Damon can do this, so can I. Come on!
These fine particles would clog your air filters and do all kinds of damage to your equipment, from cutting off your life support systems to knocking out your heat regulation.
Warning. 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 Oxygen system failure.
Well, that's Mars for you. I give it a 6 out of 10 just for the epicness of this whole death situation. Oh, and for giving you a chance to live here. Just maybe not for too long.
I'd give Mars a 0.
There's one more rocky planet lurking on the outskirts of the solar system. Hold on. My editor is saying it's actually not a planet, it's a dwarf planet. Anyway, Pluto will be the last deadly place to visit on this list, right after the giants. Jupiter is the largest planet in the solar system, and as a gas giant, it has a number of ways to kill you. Being twice as massive as all the other planets in the solar system combined, Jupiter has astronomical pressure. This planet is basically a gigantic ball of hydrogen and helium. It doesn't have a solid surface you could step on. You'd fall all the way through its atmosphere, although it wouldn't be that long of a fall for you.
Let me guess. Suffocating, extreme pressure. What else is new?
Lightning. Yeah, that's right. Jupiter is home to some of the most violent lightning storms around.
Okay, well that's great, but I don't see any here.
Well, of course not. In the upper atmosphere, the weather is not as dramatic. The atmospheric pressure here is only 1/10 of the pressure we feel on Earth.
Capsule systems are stable.
Some 50 kilometers below Jupiter's clouds, you'd feel serious turbulence. Wind here would be strong, reaching up to 360 kilometers per hour.
Static buildup detected in the atmosphere.
As these chaotic winds violently battered you through the storm clouds, the lightning bolts would strike too close for comfort. The atmosphere around you would be highly charged. And then one of these bolts would strike the capsule head on. This massive lightning would release enough energy to power a city or two. But for your capsule, it would be game over. The electrical systems would fail, the oxygen supply would fail, and the temperature inside the capsule would drop significantly. You'd now be trapped inside a powerless, leaking capsule surrounded by a deadly storm. I give Jupiter a 5 out of 10. Could recommend. This gas giant may not be as large as Jupiter, but it's definitely the most majestic. Saturn is the second largest planet in the solar system, and just like Jupiter, it's a gas giant made up of hydrogen and helium with no solid surface. Deep down in its clouds, the unimaginable pressure of this world turns hydrogen into liquid metal. And intense storms have winds raging at 1,800 kilometers per hour. It's windy, it's hot, it's dangerous. And you might die before you even enter Saturn's atmosphere. What makes Saturn the most marvelous planet in this planetary hood is also what makes it dangerous on approach. Saturn's rings.
Yeah. Okay, yeah, I see them all right.
These rings are made up of billions of small chunks of ice and rock, ranging from grains of dust to icy chunks the size of a house. Saturn has had its rings for a few 100 million years, and it'll have them for the next few 100 million years until these icy rocks rain down on the gas giant. The thing is, these rings move extremely fast, like 70,000 kilometers per hour fast. If you're not careful, your ship might just crash into them. Saturn gets an 8 out of 10. Uranus is a beautiful, stormy, fart-smelling, deadly ice giant. It has the coldest atmosphere of all the planets in the solar system. And it can kill you in many ways. One way to go on Uranus would be to suffocate in its gases.
Oh, not the fart gases! Oh.
Close enough. 2% of the Uranian atmosphere is methane, a gas that's toxic to humans. Now, 2% might not sound like a whole lot, but it's concentrated enough to kill you within minutes. Maybe Uranian high-speed particles moving at 900 kilometers per hour eroded your suit. Or Extreme temperatures of minus 224 degrees Celsius made it brittle and caused it to crack. Or hydrogen and methane had a chemical reaction with your suit materials, corroding them. On Uranus, anything could cause a breach, and even the smallest breach would lead to toxic methane exposure. But Uranus has other surprising ways to off you, like turning you into a human-sized diamond. You'd have to survive the trip deeper into Uranus to be turned into a diamond, all the way to some 10,000 kilometers below its cloud tops. That's where the pressure is so intense and the temperature is so high that carbon atoms crystallize into diamonds. About 18% of the human body is carbon, so you'd be about to undergo the most precious change of your lifetime. I'd give Uranus a 10 out of 10. Epic, sparkling, with a bit of fun. Great planet to perish on. Now, this is the last ice giant in the solar system and the most distant planet from the Sun, Neptune.
Huh. Neptune? It looks a lot like Uranus.
It's true. Neptune has a similar mass and size as Uranus, and it's even made up of some of the same materials like hydrogen, helium, iced ammonia, methane, and water. Only Neptune has one thing Uranus does not.
Extreme winds detected.
Neptune has the fastest winds in the entire solar system. These gusts reach speeds of 2,100 kilometers per hour. They're not just winds, they're supersonic winds.
Hey, nobody told me that we were filming a Top Gun sequel in here, okay?
It gets worse, too. Not only are these winds extremely fast, but they're also turbulent. They create swirling vortices that would throw your spaceship in different directions. Intense atmospheric pressure, winds, and methane ice would start ripping the ship apart. But that's not all. If you got caught in the Neptunian supersonic vortex, the winds would violently spin the ship, and this centrifugal force would exert some serious G-forces. As Neptune's winds accelerated your ship to about 10 Gs, everything inside your body would feel heavy. That would be your organs getting compressed inside your body. Your blood would pool around your legs and cause oxygen deprivation to your brain. You'd lose consciousness pretty quickly. It would only take about 5 minutes for the ship and your body to lose their structural integrity completely and disintegrate into the Neptunian atmosphere. Well, that was pretty violent. I give Neptune a 2 out of 10.
Well, I know you guys like Pluto, so since you asked so nicely, I thought I'd give you a little treat and show you what it's like here.
Pluto isn't exactly a planet. It's a dwarf planet on the outskirts of the solar system. It's smaller than Earth's moon, but even this tiny rock has ways to kill you.
It's a little cold in here, you feel that?
Temperature reading, minus 239 degrees Celsius.
Pluto is even further away from the sun than Neptune, so it barely gets any of the sun's energy. One small malfunction in your spacesuit insulation, and you'd freeze to death. You'd feel the frostbite setting in after just 30 seconds. Another 30 seconds later, your bodily fluids would start turning into icicles, and you'd get extreme hypothermia as an unpleasant bonus that you didn't ask for. After 2 minutes, your body temperature would drop below 30 degrees Celsius, which is the exact moment when you'd lose consciousness. After 3 minutes, your body would freeze and your organs would fail. You'd become one with Pluto's frozen landscape. Quick and almost painless. That's a 7 out of 10 for Pluto.
It did hurt.
You know, I'm all about sunsets, especially if I'm away on vacation. Beautiful, relaxing, they really put a cap on a great day. But while we're down here enjoying the classic fiery orange sunset, well, the rest of the solar system is putting on a light show that looks like a glitch in the Matrix. From blue sunsets on Mars to the turquoise horizons of Uranus, the universe doesn't just do golden hour, it does Technicolor fever dream. With an Earth sunset, our nitrogen-rich air scatters the blue light away, leaving the reds and the oranges. But on Mars, the fine dust is so specialized that it actually lets the blue light through, making the sun look like a glowing sapphire. Meanwhile, on Venus, the atmosphere is so thick and toxic, you wouldn't even see a sunset. Just a gradual, crushing descent into a dim, yellowish void. Talk about a mood killer for your romantic stroll. But pack your bags and maybe a lead-lined umbrella, because we're about to see how the sun and other stars say goodnight across the cosmos. Imagine a sunset on a planet that orbits a black hole. Or one that stops, reverses, and happens twice in the same day. Or a Martian sunset that turns blue. This is not sci-fi. These are real physics. You see, there are 2 trillion galaxies out there in the universe, and within them, there are billions upon billions, trillions upon trillions of stars. Our Milky Way galaxy alone has at least 100 billion planets. Think about that, 100 billion. Some orbit 2 stars. Some orbit dead neutron stars. Some even orbit black holes. The universe is a strange place, and the view is about to get spectacular. So buckle up. We're traveling from Mercury to the edge of the known universe to witness the most beautiful and deadly alien sunsets you've ever seen. And stick around to see a sunset on a planet orbiting a black hole. In our solar system, Mercury has the weirdest sunsets. The sky here is always pitch black. That's because Mercury doesn't have any atmosphere to scatter sunlight like Earth does. But even though Mercury doesn't have epic twilight, it has something better. Double sunset. Yeah, if you were standing on Mercury, you'd see the sun slow down in the sky and then stop, reverse for a bit, and then fully set over the horizon. That's not a simulation mistake. That's a normal day on this planet. Mercury has a very oval-shaped orbit, and it speeds through it faster than any other planet in the solar system. But when it gets to its closest point to the sun, it speeds up drastically, like a slingshot. On average, Mercury rotates on its axis exactly 3 times for every 2 loops it makes around the sun. But when it's at its closest to the sun for a few days, Mercury is moving around the sun faster than it's spinning on its own axis. And that creates the epic double sunset you can only see once in 176 Earth days. On Venus, you never actually see the sun as a distinct disk in the sky. That's because this hellish planet has an incredibly thick atmosphere, and the atmospheric pressure here is 93 times higher than on Earth. Unlike on Mercury, all you'd see on the surface of Venus is thick, yellow sulfuric acid clouds. Lots of them. And as the sunset approaches, from the surface of the planet, the sky never turns to starry night. Instead, the yellow glow just deepens into a dark red and then fades into a pitch black night, where no stars are visible. But you'd have to wait a long time for this sunset. One day on Venus is 243 Earth days long. That's even longer than a Venusian year, because Venus only takes 225 Earth days to orbit the Sun. But don't mix that up with the solar day on Venus, which is another way of saying a full day-night cycle. That solar day here on Venus lasts 116 Earth days, and the actual sunset isn't a 15-minute spectacle. It lasts for days. Mars has this cold, red desert vibe during the day, but as the sun sets, the sky actually turns blue. Yeah, the reason behind this is that the atmosphere on Mars is very thin, less than 1% of Earth's, and it's filled with teeny tiny dust particles, or iron oxide and magnetite. These particles are micro-tiny. They're about 30 times smaller than a single strand of your hair. Yeah, if you scale a human hair to the width of a soda can, a particle of Martian dust would then be the size of a single grain of rice. During the day, the iron-rich dust in the Martian thin air scatters sunlight. That's what gives Mars its signature red planet look. But the sunset is where all the physics get flipped. All because of what scientists call me-scattering. Those dust particles are almost as small as the wavelength of blue light, so they don't just absorb blue light, they act like tiny directional mirrors. Instead of bouncing the light everywhere, they scatter the blue light forward. So when the sun is low in the horizon and you're looking right at it, that blue light is beaming directly into your eyes, cutting through the haze. Science. Now, Jupiter is a bit of a bummer because you can't land on its surface. Now, gas giants like Jupiter and Saturn, just the same as the ice giants, Neptune and Uranus, don't have any surface at all. They're just super heavy clouds with cores at their center. So, while you can't see what the sunset looks like from Jupiter's non-existent surface, you can still look at it from Jupiter's cloud tops. From here, the sky would look dark blue, darker than the deepest ocean on Earth. And the sun here is just a tiny, incredibly bright button in the sky, only a fifth of the size we see it from Earth. That's because Jupiter is far. Yeah, it's 5 times farther from the sun than Earth. Okay, Jupiter doesn't have retrograde sunsets or blue sunsets, but it has speed. Yeah, this giant rotates incredibly fast. It makes one full rotation on its axis in just 9 hours and 55 minutes. So, in one Earth day, this giant has the sun setting and rising 2.5 times. Was a half sunset. Anyway, basically it's a sunset on fast forward. Now, while we're hanging around Jupiter, let's take a break from all the planets and look at some of the solar system's largest moons. Io is a volcanic hellscape, the most volcanic moon in the solar system. It spews volcanoes like Earth did in its early days, and it even has an atmosphere, but that atmosphere is super thin and mostly made up of volcanic gases like sulfur dioxide. Because the air is so thin, the sky here is mostly black, even during the day. And sunset here is no regular sunset either. It's a sunset/solar eclipse. Yeah, every 42 and a half hours, the sun hides behind Jupiter. And it's not a fast kind of eclipse either. If you were watching sunset on Io, you'd see the sun disappear behind the gas giant for 2 solid hours. And this is Europa. It's quite the opposite from the volcanic world that is Io. This moon is icy. Europa has a very thin oxygen exosphere. It's like an atmosphere, but way too thin. So the sky here is black even during the day. But when the sun finally sets, Europa gets a glow up. Literally, this moon is being constantly bombarded by intense radiation from Jupiter. And all that radiation slams into the ice on the surface and makes the ice molecules release energy as light. So as soon as that tiny sun vanishes below the horizon, the ground beneath your feet would start to shimmer. The landscape would glow with a faint light, like you wouldn't even need a flashlight to see where you're walking. Okay, next up is the solar system's heavyweight champion moon, Ganymede. Yeah, this moon is so huge it's bigger than Mercury. If it orbited the sun instead of Jupiter, we'd call it a planet. And it's the only moon in the solar system with its own magnetic field. That means a sunset on Ganymede comes with a light show. As twilight hits, you'd see auroras. Yeah, just like Earth's northern lights. Well, almost. The Hubble telescope has detected Ganymede's auroras mainly in ultraviolet, so you wouldn't see them in our simulation. And you wouldn't really see them if you were standing on the surface, unless you used specialized equipment. And finally, Callisto. This rock orbits Jupiter, only much farther away than its other large moons. From here, Jupiter would look about the same as a grapefruit held at arm's length. Now, you'll see the same kind of sunsets as you would on Io, with Jupiter blocking the sky, but Callisto doesn't get an eclipse every day. Yeah, it has a tilted orbit and often misses Jupiter's shadow. You'll have to wait 3 years to see one of these sunset eclipses. Okay, enough with Jupiter. Let's move on to the moons of Saturn. This is Titan, Saturn's largest moon, and it's a special moon. No, it doesn't have volcanoes like Io or glowing ice like Europa. It's got a thick atmosphere, and its atmosphere is even denser than Earth's. But even more than that, Titan is covered with lakes. Only these lakes aren't made of water. These are lakes of liquid methane and ethane. In this thick atmosphere, the sunset would take the landscape from hazy orange to deep brown. And with Saturn so big in the sky, well, what a view! Now, speaking of Saturn, this planet, just like Jupiter, is a gas giant, so no surface to land on. And just like on Jupiter, you'd have to watch the sunset from the cloud tops. But the sunset isn't the main event here. The rings are. During the day, the icy rings reflect sunlight, and as the sun sets, you'd watch the shadow of the planet itself creep across that arch, extinguishing the ring light section by section. It's not just the sun going down, It's the lights going out on the biggest structure in the solar system. Man, I wish Earth had something like that. Okay, past Jupiter and Saturn and all their moons, there's Uranus. This planet is weird. It rolls around the sun on its side instead of orbiting it straight like other planets do. Because of this tilt, if you were at the pole of Uranus, you'd have to wait 42 Earth years for the sun to set. It would just spiral around the sky. But when the equinox finally comes and the sun does set, it's beautiful. The atmosphere of Uranus is full of methane, and methane is a gas that absorbs red light. So as the sun dips, the sky doesn't turn orange or pink. It fades from a bright cyan to a deep turquoise color. Makes me feel kind of cold. Next up is Neptune. This is the furthest planet from the sun. I know this because Pluto is not a planet, not officially. Neptune orbits the sun 30 times farther than Earth does, so things here are pretty dim. Out here, the sun is 900 times dimmer than it is on Earth. A sunset on Neptune is a shift from blue to total blackness, so not as spectacular as you might have pictured. Moving on. To Pluto. I know, I said it's not classified as a planet, but it still holds a special place in the solar system, and in my heart, and in the comments section where you're constantly telling me it's still a planet, but it's not. A dwarf planet / X full-on planet, it even has its own moon, Charon. Now, Pluto is even further from the sun than Neptune, so it's even darker here on this rock. If you stood on the surface of Pluto at sunset, you wouldn't see a black sky, you'd see a blue one. A really, really, really dark blue sky. And you could see Charon from here, forever locked in the sky. That's because Pluto and its moon are tidally locked, so here you go, a sunset on Pluto. Now, as sunsets seem to look darker and more boring and more darker and more boring as we get further out in the solar system, well, I think it's time to travel outside our planetary neighborhood. Okay, this is Kepler, but not your favorite 22b. This is Kepler 444c. This one is half the size of Earth. This rocky planet is 119 light years from Earth, where it orbits a dim and small K-type star. But it orbits really close, way closer than even Mercury orbits our sun. So that small K-type star looks massive in the sky. And this rock is Kepler 452b. Which scientists often call Earth 2.0, mostly because it orbits a similar sun in its habitable zone. The main difference is that its star is about 1.5 billion years older, so it's 20% brighter than our sun. You see, stars like our sun tend to get brighter when they get older, just before they turn into red giants. So a sunset here would be bright, but very similar to Earth's. And in case you forgot what an Earth sunset looks like, well, here's a beautiful sunset simulation for your reference. Another Earth-like planet is TRAPPIST-1e. Look, it even has auroras and a beautiful atmosphere. But you're not here to watch regular sunsets. You want to see the epic stuff. I get it. And I give you PSR B1257 plus 12C, or simply Poltergeist. It's one of the first planets ever discovered, but it doesn't orbit any kind of star. It orbits a pulsar. This pulsar is called PSR B1257 plus 12, or LIC. It's only about 20 kilometers in diameter. From Poltergeist, it looks tiny. Yeah, that blindingly blue-white point of light? That's the pulsar. Pulsars are extreme. They're neutron stars spinning so fast that they sweep beams of radio waves and other radiation across space like cosmic lighthouses. Some blink just a few times per second, and the fastest pulse hundreds of times per second. It's incredible. This specific pulsar spins 161 times per second, so the sunset here has a bit of a strobe effect. And it goes back and forth like that as the planet turns away from the pulsar and back at it. Things are spinning fast here. Now, this celestial rock doesn't have any nice name. It's called WD1145 plus 017b. Scientists don't bother giving it a more memorable name because it's being vaporized by the white dwarf it orbits. The white dwarf is about the size of Earth, but it's as massive as 60% of our sun. It burns with a hot blue-white light, and with every sunset, it rips the planet or a planetesimal that's left of a planet apart. But this is nothing compared to the scariest of sunsets. The kind of sunset that happens when a planet orbits a black hole. This is an extremely beefy, supermassive black hole, Holmberg 15A star. It's a black hole in the middle of the galaxy, Holmberg 15A, which is 750 million light years away. This black hole has a mass of 22. Hello, What Ifers, and welcome to the latest installment of What If Extended? What If Deep Dive? No, what if the movie? No, but that does sound interesting. How about Dateline What If? Yeah, I'll take it away and I'll workshop it and I'll get back to you later. But we'll just leave it as a What If marathon for now. Anyway, today's focus is on that infamous dwarf planet in the Kuiper Belt, the former 9th planet in the solar system, Pluto. Now, I take no joy in the fact that Pluto is no longer classified as a planet. I accept it as a scientific fact, not gonna argue it like some of you in the What If community. I'm just gonna embrace it and move on. Sometimes things that are 5.8 billion kilometers away aren't what we originally thought they were. Heck, sometimes things and people on our own planet aren't what we thought they were. Coming up in the marathon, we'll find out what a sunset looks like on Pluto, what it would be like to die on the dwarf planet, and what life on Earth would be like if our planet were the same size as Pluto. Hint, it's not going to be great. But first, before we get to all that, let's get to know the place a little better. I sent our trusty crash test dummy, our experimental regenerating lizard man Chase, to set foot on Pluto and find out what it's really like on the surface.
What up, guys? You asked and I delivered. I'm here on Pluto, and I'm gonna give you 3 reasons why Pluto is a planet, baby. Why? Because someone's gotta stick up for this little guy. Look at him, he's so cute.
Analyzing conditions. Atmosphere, nitrogen, traces of methane, and carbon monoxide. Current temperature, minus 232 degrees Celsius.
Yeah, oof, that's chilly. Well, that makes sense. Pluto is 6 billion kilometers away from the sun. So what makes a planet a planet? It's literally just three things. The first condition is that it has to orbit a star. Check please. The sun is barely visible from here, but it's there, and Pluto orbits it, so Pluto 1, haters 0.
Distance to the Sun, 5,867,639,023 kilometers.
Exactly. It's like 0.1% the brightness here that you've got over there on Earth. It's really dark, right? Hey, I think I see some mountains over there. Gotta check them out. Rico, remember that time we watched Mean Girls?
Negative.
It got me thinking about, like, every time I've been bullied or rejected by all those alien hotties I ask out. I mean, that's not important. And no one has been more bullied than Pluto. For like 80 years, it was considered a planet. And then, like, out of nowhere, it becomes a dwarf planet? Like, what's up with that? Thanks, Neil deGrasse Tyson.
Pluto was disqualified as a planet due to the discovery of large objects around its orbit.
Man, who didn't they punish back then? First Lindsay Lohan, then Britney Spears, then Pluto loses its status. Man, the 2000s were cruel. Yeah, this is definitely a mountain, and that's something a planet would have.
The presence of landscape elevation is not part of the planet definition specified by the International Astronomical Union.
But I mean, like, alright, but what if the mountains have water ice? I mean, look at this stuff. That is ice!
Many non-planetary bodies feature these landscape traits.
Right, yeah. I mean, I knew that from my various trips to moons and the suches. Alright, I tried to score some points for Pluto here, but Rico is being real annoying with his International Astronomical Union or whatever. But he's right. There are technically 3 criteria for a planet to be a planet. And number 2 is that it needs enough mass and gravity to form into a sphere. Some asteroids out there have wild shapes. None of them are flat though. Sorry, flat earthers. You guys are still wrong. There's a comet shaped like a bone and a cigar, and this one looks like a rubber ducky. That's a good one. So all of these wild shapes occur because they don't have enough gravity to turn into a sphere shape. But Pluto does. I mean, look at it. It's round. Pluto 2, haters 00. Speaking of haters, I read some of your comments the other day, and gotta say, some of you hurt my feelings. You think I'm AI? There's no artificial intelligence in this handsome space explorer. Everything you see is real. Go over to Patreon, see what I mean. Now, back to Pluto.
You are forgetting the third criterion for planet qualification. A celestial body must have enough gravitational force to clear the area in its orbit. Pluto shares its orbit with small, icy bodies in the Kuiper Belt, so it cannot be classified as a planet.
Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet. Pluto had it coming. Kidding. Just get over it.
2 out of 3 ain't enough? Ugh, man, the Astronomical Union are such keeners. I mean, Pluto has enough mass and gravity to form it into a sphere, but not enough to impact the objects around it? Ugh, seems pretty arbitrary to me. So basically, it got kicked out of the Planetary Cool Kids Club for being too skinty? Ugh. Whoa! Whoa! Rico, you're supposed to warn me about these kind of things. Bad things tend to happen to me.
Acknowledged. Danger. Crater detected in front of you.
Are you serious? Yeah, I see the crater, Rico. Thanks. Damn! Look at this thing. It's huge.
Craters on Pluto range up to 260 kilometers in diameter.
Whoa. Isn't that like half the size of this boulder?
Pluto is 2,376.6 kilometers wide. That's 2/3 the diameter of the moon.
What? 2,400 kilometers? I mean, like, I could walk that in 4 days.
Inaccurate.
I mean, okay, maybe not walk, but if I ran, I could for sure do that in 4 days.
The average maximum run speed of a humanoid is 8 kilometers per hour. You are well below average human.
Okay, Rico, all right, enough of that. It's still a very small planet, though.
Still not a planet, but yes.
Right, so Pluto's giving dwarf planet, so we just need to figure out a way to bulk it up. Give it a little ass steroids, you know? Make it a heavyweight champ. Oh, I've got it. Pluto lives in the Kuiper Belt, the region of space just beyond Neptune's orbit, and that place has a ton of icy objects and asteroids. Some of these guys are pretty big. I mean, not big enough to be called planets, but maybe if we put them all together, we could make the biggest planet of all time.
Calculating the likelihood of creating the biggest planet of all time. 0.0005%.
Rico, buzzkill, okay? I was being hyperbolic.
I cannot compute tone.
Okay, well, not the biggest planet of all time, but bigger than it is today. Let's see, if you... Okay, so you gotta take the mass of the... How do you start? And, okay, actually...